2. Verifying trig identities. So verifying trig identities means proving that something is an identity. Usually this is going to involve transforming one side of an equation into the same form as the other side by using our basic trigonometric identities and some basic algebra. We can transform either side, or we can transform both sides separately into forms that are the same. So some things that we can do. We can transform the more complicated side of the equation into the simpler side. We can substitute one or more basic trigonometric identities to simplify expressions. We can factor or multiply to simplify expressions. We can multiply expressions by an expression equal to 1. And we can express all trigonometric functions in terms of sine and cosine. So, for instance, to verify that secant squared x minus tangent x cotangent x equals tangent squared x, one thing that we can do, right? So secant squared or secant squared theta, whatever, x, theta, same thing. Cotangent theta is equal to 1 over tangent theta. And so when we multiply tangent theta by 1 over tangent theta, our tangent thetas cancel out, and this gives us secant squared theta minus 1 equals tangent squared theta. If we add 1 to both sides, we get that secant squared theta equals tangent squared theta plus 1, which is a Pythagorean identity. And we know that our Pythagorean identities are true, so this is verified. When working on a mathematics assignment, a group of students derived an expression for the length of a ladder that, when held horizontally, would turn from 5-foot wide corridor into a 7-foot wide corridor. They determined that the maximum length L of a ladder that would fit was given by L theta equals 7 sine theta plus 5 cosine theta over sine theta cosine theta, where theta is the angle the ladder makes with the outer wall of the 5-foot wide corridor. When their teacher worked the problem, she concluded that L theta equals 7 secant theta plus 5 cosecant theta. Are the two expressions for L theta equivalent? So we want to verify that 7 sine theta plus 5 cosine theta over sine theta cosine theta equals 7 secant theta plus 5 cosecant theta. So using a basic principle of algebra, we can say that this is 7 sine theta over sine theta cosine theta plus 5 cosine theta over sine theta cosine theta. We can split this fraction up. Divide both parts by the denominator. Here our sines are going to cancel out, and here our cosines are going to cancel out. And so that's going to be 7 over cosine theta plus 5 over sine theta. 1 over cosine theta is secant theta, so that's 7 secant theta. 1 over sine theta is cosecant theta, so that's 5 cosecant theta. And that is equal to what we got up here. So, transforming the more complicated side of the equation into the simpler side. Verify that sine A over cosecant A plus cosine A over secant A equals cosecant A minus cotangent. So cosecant squared A minus cotangent squared A, which is an identity. So go ahead, we want to turn our cosecant and our secant into sine and cosine. So this is sine A over 1 over sine A plus cosine A over 1 over cosine A, which means that we multiply sine A by sine A to get sine squared A, and we multiply cosine A over cosine A, cosine A by cosine A to get cosine squared A. So we get sine A plus sine squared A plus cosine squared A, which according to the Pythagorean identity is equal to 1. So we get 1 equals cosecant squared A minus cotangent squared A, which is also a Pythagorean identity, right? If we add cotangent squared A to both sides, 1 plus cotangent squared A equals cosecant squared A is also a Pythagorean identity. Find a numerical value of one trigonometric function of x if cotangent x over cosine x equals 2. So this is not an identity. There is some value of x that makes this true. But what we're going to want to do is we're going to want to turn that cotangent into cosine x over sine x and divide that by cosine x. And so that's going to cancel out our cosines and make this 1 over sine x equals 2, which would be cosecant x equals 2. Or the reciprocal would be that sine x equals 1/2. Right? Cosecant is 1 over sine. You could also do it this way. If you multiply both of these by sine x and sine x, you would get 1 equals 2 sine x and divide by 2. And so you get sine x equals 1/2. So you can get cosecant x equals 2 or sine x equals 1/2. And then look on our unit circle. Where does the sine equal 1/2? That's going to be at pi over 6 and at 5 pi over 6. Both of these are going to have a sine equal to 1/2. The problem doesn't give us any limits on x, so if x could be any real number, we also want to include coterminal angles like 13 pi over 6. So that's where we do the plus 2 pi n, where n is any integer.